All right, so we're going to talk about the process for finding a reference angle given either degrees or radians. Works the same way, just with slightly different looking formulas. To find the reference angle, our first step is to find the coterminal angle between 0 and 360 degrees. Just make sure it is less than 360. If it equals 360, then you want to subtract 360 again. So you'll keep adding or subtracting 360 until you find this coterminal angle between these values. From here, you want to locate the quadrant. You want to actually graph the angle that you now have found between 0 and 360, because you will need to apply the quadrant's formula for the reference angle. If you are in quadrant 1, you have your reference angle. It's done. If you're in quadrant 2, then your reference angle is found by either taking 180 degrees and subtracting the angle that you now have, or taking pi and subtracting the angle you now have. If you're in quadrant 3, you take your angle and subtract 180 degrees or pi from it, and that will give you the reference angle. And if you're in quadrant 4, you take 2 pi and subtract your angle from it, or take 360 degrees and subtract your angle from it. In all of these cases, once the process is done, you should get an angle between 0 and 90 degrees, and that should tell you that you have the correct reference angle. One thing to be aware of, if your angle ends up being a quadrantal angle, meaning it's on one of these axes, then you would have something like 0, 90, 180, 270, or back to 360. And if you had it in radians, it would be 0, pi over 2, pi, 3 pi over 2, or 2 pi. When you're dealing with those, just know that either of the formulas will generally work. So if you end up here with your angle, it's already done for you. 90 degrees is your reference angle. Or if you plug 90 into this formula, 180 minus 90 is 90 again. If your angle is here, 270. 270 minus 180 gives you 90, whereas 360 minus 270 also gives you 90. So just use the formulas that surround the quadrantal angle if you have one of those cases. Otherwise, just plug in the formula for the quadrant you need. So for this example, we have 540 degrees. Our first step is to find the coterminal angle by subtracting or adding 360 degrees. In this case, we will subtract 360 because it is a positive number. If it were negative, then we would add 360 to it. So if we subtract 360, we'll be left with 180 degrees. At this point, we will then graph 180 degrees to find the quadrant. If we graph, we start at our initial side, which is the positive x-axis, rotate counterclockwise. This is 90, this is 180, so we'll stop. That tells us this is our angle. And notice this is one of the quadrantal angle cases. You can use either quadrant 2's formula or quadrant 3's formula. In quadrant 2, we would have 180 degrees and subtract our angle theta, which is 180, which would leave us with a reference angle of 0. If we use quadrant 3's formula, we would have our angle, which is 180, and then subtract 180 from it. In this case, we would still get 0 degrees. So it works either way. Our reference angle of 540 degrees is 0 degrees. So take a moment, pause the video, and see if you can find the reference angle of 480 degrees. Okay, so trying this out, we first start by subtracting 360 degrees, which gives us 120 degrees. Next step is to graph it. If we graph this, remember this quadrantal angle is 90 degrees, so we're going to go just a little bit past it and draw our terminal side, which means that we are in quadrant 2. In quadrant 2, our formula says take 180 degrees and subtract your angle. So 180 degrees minus 120 degrees gives us 60 degrees. So 60 degrees is the reference angle for 480 degrees. Let's go ahead and try one more, but with radians this time, just to show that this works regardless of whether you have degrees or radians. So for this example, let's say we wanted to find the reference angle for 11 pi over 6. To find the reference angle of 11 pi over 6, we would start by adding or subtracting 2 pi if we need to. But if you add or subtract 2 pi to this, in this case subtract, you would end up getting a negative number because 2 pi is the same thing when you get a least common denominator as 12 pi over 6, which is greater than 11 pi over 6. Meaning you don't have to do step 1. It's already done for you in this case. At this point, you just have to graph 11 pi over 6. And when you graph 11 pi over 6, you'll find that it is located in quadrant 4. Because it is almost equal to 2 pi, it's just a little bit less. 2 pi is right here, so it's almost a complete rotation, but just not quite. Meaning we need to use the reference angle formula from quadrant 4, which is 2 pi minus our angle, 11 pi over 6. When we do this, we just did one similar to it up here when we were comparing whether we should find a coterminal angle. We need to find a least common denominator. So if we put 2 pi over 1 and we find the least common denominator between these two, we'll have to multiply by 6 over 6 again, which gives us 12 pi over 6 minus 11 pi over 6, which leaves us with pi over 6 when we subtract the numerators and keep the denominator. Meaning pi over 6 is the reference angle of our original angle, 11 pi over 6.